Hello and welcome to this Tovi tutorial. We're going to walk through the configurable marginal distribution sampling gap filling tool. Now, prior to using this tool, you will have wanted to go through the stages of importing your eddy profiles and also importing your external weather station data. From there, you will have done some quality screening operations to make sure you've cleaned out outliers in your fluxes and your biomet variables. Then you will have wanted to make sure to go into your biomet gap filling tool and create full data sets for all of these biomet variables, which are then used as drivers inside the gap filling tools. Now, if we go into our toolbox here, you can see that we have a set of tools used for gap filling. This is that original MDS gap filling tool that came from the Max Planck Institute and Marcus Reichstein's paper. And in that tool, you can do fluxes for CO2, sensible heat, and latent energy. Now, with this new configurable tool, you're able to do gap filling for additional fluxes, such as methane or momentum. And in addition to that, there's some more flexibility with the drivers and how you use those and select them, and also a way to set up time windows for when to apply certain drivers, and we'll get into that in a moment. Now, we can also have a workflow view. Some of you may have also gone through and done U-star filtering and maybe footprint analysis. And so you have a data set with quite a bit of gaps that need to be filled. So we're going to go ahead and click into this configurable MDS gap filling tool. Once we're in here, we want to select the variables. So if I click here, you can see there's a list of variables and fluxes that we're able to gap fill. For this example, let's go ahead and pick our CO2 flux. Let's also pick our latent energy. And for a third one, let's do our methane fluxes. Okay, now this particular data set that you're seeing comes from a rice paddy. It's about 8 months worth of data. You can see there's a growing season here that extends 3 or 4 months from May into July and August. And what you can do in this tool, if down here is select drivers that'll be used in the gap filling tool, in this case for this entire window. Now, as you know, you might have different drivers depending on the growing season or if it's more of a dormant season. So what we can do is select time windows by clicking on this plus button. Now let's assume I just pick a date to show you an example of middle of July. I can select that, hit OK. And what you'll notice now is I have a window created here, which I can enter certain drivers for. And then I have a second window here, which I can enter either the same sets of drivers or different sets of drivers. All right, so let me go ahead and delete this one because that's not a practical cutoff point or a transition period. Now, if we do look at this data here, you can see that as the growing season comes and goes, you have what we might consider transition periods in which the drivers may be more influencing on the fluxes over on the left-hand side than during the growing season, and similarly towards the end of the growing season. So we're going to set up transition windows where we can look at 2 sets of drivers for the same time period. So let's go in here again. We're going to create a transition period this time. And let's say when we looked at those dates, it was somewhere towards the end of May, say May 24th. I'll go ahead and select that. And let's go ahead to the end of May 31st and select that. I hit OK. Now what you see is we have one window here and a second window here. And you'll notice this period, this transition period between the 2 windows overlaps. Let's create a second one towards the end of the growing season. Again, click on the plus sign. And that was somewhere in September. If you'll look at your own data, you might be able to pick a specific date that best to give you the best results. And let's go to September 20th. And I hit OK. Okay, so I have one window, a second window, and now a third window. And the second window has some transition periods with both the first and the third. Okay, now we can go over and start setting up our drivers. we do have the option for setting up drivers that run during the daytime and different drivers for the nighttime. For this example, I'm going to use the same drivers for both daytime and nighttime. Okay, so for the CO2 fluxes here, the primary drivers typically in this dormant season are air temperature. So if I click here, you can see I have a list of variables to select from, but I can also start typing in the variable name and bring that up quicker. You can see I have this merged variable, which was created in the Biomet gap filling tool. It's a complete data set. And over here, I can select the tolerance, say plus or minus 2.5 degrees. And that's what the gap filling tool will look for in the data on both sides of the gaps. Let's go ahead and also pick a second driver. In this case, I'm going to choose the soil temperature. You can see I have several soil temperature measurements, but here is one that I have gap filled in a complete data set. The tolerance I'm going to use for this is 2 degrees. Not as much variability down in the soil. Okay, now let's move to the second window. Now that we're in the growing season, we're going to have a different set of drivers that influence the fluxes here. So the most obvious and important one will be our incoming solar radiation. So I can find that variable here, select that. Now here I can choose to use 2 different tolerances. For when there's low light conditions, I'm going to use 20. And then during the day, when I have higher light conditions, I'm going to use a plus or minus 50 for that variable. Now we can also, again, choose air temperature as an important driver. A 2.5 tolerance, and then let's also do vapor pressure deficit. Okay, we got a VPD data set here that we can use as well. I'm going to use plus or minus 500 pascals for the tolerance. Okay, let's go to the third window now. What you can see is that the data here and fluxes are very similar to the first window. It's still that dormant period where the rice isn't growing. So what I might want to do is select the same drivers, and I can either set those up by doing the same process, or I can go back to this first window, and down here I have the option to copy either drivers or settings. So let's first copy these drivers, and I'm going to take the drivers I used in my first window and copy them here to my third window. And now if I go down again to look inside that third window, you can see those drivers are brought over along with the tolerances. Okay, so we're all set to go for our CO2 flux. Let's go ahead and move towards latent energy now. Now, since latent energy and CO2 fluxes have a very strong relationship, I'm going to decide, instead of setting up new windows and trying to figure that out again, I'm just going to copy those over from the previous CO2 flux configuration. So I go back up there, and now I can click on this copy settings. Okay, and so I have some options to either copy over the windows and the drivers, or the windows only. And in this case, I'm going to copy both the windows and the drivers, and I'm going to copy it into my LE fluxes. I hit OK. Now when I come down to latent energy, you can see I have those exact same 3 windows are all set up for me, and all the drivers and variables are also installed. So that makes it very quick and easy for me to do this. Let's move to our methane flux. Okay, I'm going to do the same thing here. I want to copy over the windows, but probably not the drivers, because methane has different sets of drivers potentially than our CO2 flux. So if we go back to CO2 flux, I want to copy the settings. I'm going to say I want to copy the windows only. I'll deselect latent energy and select my methane fluxes and hit OK. So now I come down, I can see the windows, but now as I look at the data, I realize that I had this transition period that doesn't seem to make sense for my methane fluxes. It looks like here there's more of a sharp cutoff. Potentially that's where the water table depth changed significantly, or maybe there was water on the rice paddy, something like that. So I'm going to go ahead and edit the window, and I can do that by clicking here. And instead of a transition period that's shown here, I'm going to change it to a date. Let's go ahead and say that looked like it was around mid-August. So I'm going to move here to August, let's say 18. Hit select, and we are ready. Now again, we have our 3 windows, but instead of a transition period here, we just switched to a new set of drivers. Okay, so let's go ahead and fill these out real quick. For methane, what seems to be an important driver is the soil temperature. So we're going to find that quickly. Here's our filled in data. We'll put 2 degrees, and we'll do some air temperature as well during this particular season, 2.5, and we're good for that window. As we move to the second window now, this is during the growing period, and the rice is growing, and so the drivers here now can be something more like water table depth, or maybe air pressure, wind speed, maybe even CO2 flux, ecosystem respiration. What I'm going to choose, which seems to be a very impactful driver, is the soil water content. So I can come in here and find those probes, and I have a bunch of them. Here's the one that I've already filled in through the gap filling tool for biomet variables. I'm going to use 0.05 for the tolerance. Then I'll go ahead and pick soil temperature again. That's still an important driver. And air temperature. Okay, and I'm going to use those same tolerances that I've been using throughout. Finally, we have the third window here, and just like in the previous variables, window 1 and window 3 are very similar, so I'm going to use the same drivers in both of those. I come here to the first window, copy drivers to my third window, and hit OK. Now you notice we're ready to start and go through this and let the gap filling tool run. To do that, we just click here on the Start button. Now this will take a few minutes, and then we'll have the results pop up, and we'll take a look at those. Okay, now here we are on the result page. You can see that we have our data set shown here with the original data shown in blue, our gap-filled data shown in red. Now here I'm looking at the full timeline, but I could go through and look at each particular window to see how that data was gap-filled. What you'll notice is there's several of these windows are colored red. In this case, they're the transition periods. And we want to address which results we're going to use from the gap filling tool during that period. So if we go ahead and select this one, and you can zoom in on this data set. So I'll come here and draw a window through here. Okay, and what you'll notice is that for each of these gaps, there's been 5 ways to compute the fluxes to fill those in. So if we look at these one by one, this first one is using the drivers and the data from the left hand or the preceding window to fill the gaps here. And you can see that it does a good job here, and then it comes off the real data as we move towards the right. Now if we use the data from the right hand window, again it looks a little bit better on this side, but maybe not as good here. Then we can use the mean value. So the mean is the average of the fluxes computed using the left hand drivers and data and the right hand window data and drivers. We can also take that mean and weight it based on the QC flags that were produced during the gap filling tool. And this one actually weights the mean by the proximity of the window. So the data more on the left hand side is weighted based on the data and drivers in this left hand window, while over here the gaps are filled and weighted based on data and drivers in the right hand window. Okay, so let's go ahead and pick one to use during this situation. I'm going to go ahead and pick the right hand one. That one seems to fit pretty well. And then I can come on down and enter into this second transition window. Let's take a look at the data again and zoomed in view. Okay, now when I look here and I start looking at the 5 different results, I can see if I pick this left-hand one, the data is filled in, but it looks like there's a lot of spikes and variability. even though my real data starts to smooth out on the right. Now if I decide to use the drivers and data from the right-hand window, you can see I get some smooth out results, but then the results aren't quite matching the variability I have in the CO2 fluxes over here on the left. So this is a good example where I might want to weight these by proximity. And you can see as the data smooths out, the gap-filled results are also smoothed out. Okay, we can quickly now go to the latent energy, because we won't be able to move on until we've addressed these transition windows for all three of our variables. I'm going to go through these quickly just to show an example. I'm going to pick the left-hand results to fill in here. And with this one, I'm going to go ahead and pick the mean value. And then let's drop down to our methane. Now remember here we just have one transition period, and so we only have to address which results we want here. I can again zoom in and take a look at how the results look and determine what I want to do as far as selecting the best results for doing my gap filling. I'm going to go ahead and pick the mean. That looks pretty good. All right, so now I've gone through and I can either finish the tool or I can go back to my settings and maybe I want to select some different drivers and do some further analysis. I can change some tolerances and see if I can improve some of my results. But before we can do that or finish, you can see there's two other options here for looking at the results. We have a fingerprint plot. Here we just have a quick show of our original data and then our gap fill data. So this is the results for methane here. I can also go look at our CO2 fluxes, and if I want, I can pick a particular time window to zoom in and look at as well. Now in all these plots, you have the ability to save these images, say if you want to use them in some kind of a poster or presentation that you're doing to show your research. Okay, now let's look at the stats page. So here we have the statistics from the tool, and we have an uncertainty plot here in the top. And then we have all the statistics for how the tool went. So for example, I'm in the CO2 flux. I can go to this first window and I get some information about the 3 longest gaps that had to be filled, and then what the quality of the results are. So I get a percentage of flag 1, 2, and 3 based on the results that came out of that. I can do the same thing for any of these variables. Here I can go to methane and have my uncertainty plot, and down here I can see, for example, the 3 longest gaps basically were somewhere between 1 and 2 days. And if I look over here, I had pretty good results for the gap filling tool. So with that, that concludes this particular tutorial. To move on and have this take effect, you want to go here to click on Done with the configurable gap filling.